We're going to talk about the Secant-Tangent Product Theorem. We're at 12.6c. If you missed the two previous videos for this lesson, 12.6a was about Chord-Chord Product Theorem, and 12.6b was about Secant-Secant Product Theorem. They're linked in the description with the geometry playlist. A tangent segment is a segment of a tangent with one endpoint on the circle. So AB, segment AB, and segment AC are tangent segments. So for your notes, we've got the Secant-Tangent Product Theorem. It's theorem 12.6.3. And it says, if a secant and a tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external segment equals the length of the tangent segment squared. We have secant AC, this whole thing, and tangent AD right here. And they intersect the exterior of the circle at A. So our conclusion is that AC, this entire length, times this little external segment right here, is going to be equal to this length squared. We can use the secant-tangent product theorem to find the value of x. That would be the length of this tangent segment. Using the theorem, we've got SQ, this entire length, times RQ, its external segment, is equal to PQ squared. It's giving us that this is a 5 and that's a 4, so we have 5 plus 4, which is a 9, times the external segment 4. That's going to give us a 36. And this is going to be x squared. We remove the 2 exponent by putting a radical around the 36, and it's a positive or negative square root of 36, because negative 6 times negative 6 equals 36, and positive 6 times positive 6 equals 36, but lengths are positive values, so we know x is equal to 6. We can find the value of x in this diagram. We can see the tangent segment is x. We've got AC, we've got AB, which is an 8, and BC, which is a 6. AC, the whole length, multiplied by BC, this external part, is going to equal DC squared. AC is 8 plus 6, BC is 6, so we've got a 14 times 6, which gives us an 84. We remove the 2 exponent by putting a radical around this side. We've got the square root of 84. And for those of you who don't know how to do this, I'm going to have links to my Algebra 2 7.2a, b, and c videos that teach how to do this. But what we do is we factor out the perfect square. So 4 would be a perfect square. So we have 4 times 21. That's an 84. And the root of the product is equal to the product of the roots of each factor. We've got the square root of 2 squared times the square root of 21. We reduce the index of the radical and exponent with the 2, and we get 2 square root of 21 is equal to x. We can rewrite it using the symmetric property of equality, flip it around, and put x is equal to 2 square root of 21. So again, if this confused you, there's going to be links in the description to do this, because you're probably going to have this in homework or on a test. We can find the value of x. Now it's on the inside of the circle. We have JL, this entire length, times JK, this little external segment, is going to equal JM squared. We see this is a 7, that's an x, so we have 7 plus x. Remember, we add them. I'm going to multiply it by that little external segment, 7, and it's going to equal 10 squared. We know right away that 10 squared is a 100. We distribute this 7 into the parentheses and get 7x plus 49. And now we can subtract this 49 from each side. We're trying to solve for x, remember? That's going to give us 7x is equal to 51. We divide both sides by 7, and 51 sevenths is 7 and 2/7. So we know x is equal to 7 and 2/7, whatever the units are, centimeters, inches, whatever, meters. So we're going to finish up Chapter 12 with Lesson 12.7. We're going to learn about circles in the coordinate plane and equation of a circle. Then we're going to move on to Chapter 13, which is all about probability. We'll talk about permutations, stuff like that. So again, if you missed 12.6a and b, we talked about Chord-Chord product theorem in 12.6a and Secant-Secant product theorem in 12.6b, and they're linked in the description. I hope you have a great day, and I'll see you next time. Bye.